Hi. So how many of you are from the offensive side of security? थोड़ा और ऊपर. All right, okay. And defensive side of security? एक ही हो मतलब. All right, okay. Okay, saw you. All right, so, acha, and we have done pen testing before? Offensive wale? Yes. All right. So today, right now, we'll be talking about AWS and finding and detecting threats. We have Avinash here, who is a lead threat detection engineer at Salesforce. So for both offensive and defensive, it will be a really good deep dive insight about how do we detect threats in the AWS cloud environment. To you, Avinash.
Thank you. Hello, good evening all. I hope you had a good time today. Today we'll speak about how we leverage GuardDuty in cloud and then do it effectively at scale. As we move forward, this is the flow that we'll go. We'll do an introduction of what we are going to talk about, and then we'll move about understanding what is basic GuardDuty. GuardDuty does not need any introduction, but we'll just touch base. And then we'll address what are the current detection strategies that are being followed widely in the industry. And then we'll see why is it failing right now, and then what is the proposed strategy that I'm going to give a different perspective today. And then we'll do a small recap with a small story of what we discussed, and then we'll conclude the session. About myself, I am Avinash Reddy Thumma, lead threat detection engineer at Salesforce. I have about 13 years of experience in cyber field. Right now in detection, but I have worked in different roles like IR, cloud forensics, etc. So in my last 13 years, I worked in 5 companies. So you can think I worked in different range of work streams and then worked with multiple teams. So the problem that we are going to talk today exists everywhere, almost everywhere. And why should you listen to me? Collectively that I'm going to prove, or I'm going to say that you will also realize that the way we are using GuardDuty is not really that effective. And why is that? And then how is a new perspective that will be helpful for each of you. If you are from red team or offensive team, you will identify that there are so many loopholes within the current system, and then how you could leverage easily. And from defensive background and from freshers, you will understand how weakening is our detection system right now, and then how we can leverage with a new perspective. And if you're still wondering, I don't care, mujhe kya milega aaj? I think there are 2 exciting gifts today. If you pay attention and stay focused, there are 2 challenges you could win. It's up to you. These are the 2 really interesting gadgets. One is portable speaker, and then one is ANC earbuds. I think so you can keep your mobiles off and then stay focused. As I said, we'll move to understanding GuardDuty, and GuardDuty does not need any introduction. But considering there are freshers and new folks to the industry, I'll just give a brief that GuardDuty is a native detection service that is offered by Amazon AWS, and then it continuously monitors the cloud activity, API calls within the AWS accounts, and it identifies threats, and then it throws out alerts. And then if we consume in the production setting, we'll do a cloud IR of what's being suspicious and what's malicious, and then respond accordingly. And in Amazon terms, they call it finding types, which are essentially as signatures, you could say, where in the Amazon site itself, there are about 180 different finding types that Amazon has right now for GuardDuty. And then once you enable it, foundational ones are free, so they are enabled by default. So it works against multiple resource types, all of those 180 different signatures or finding types based off EC2, IAM, S3, etc., etc. There are multiple things. And if you go deeper, look at the findings table. The first column is the finding type, meaning the signature name or the finding name. First one is discovery S3, anomalous behavior. That's the finding type name. And the second column is resource type, meaning it's working on S3 type. And the log that is being looked at is the foundational data source, which is CloudTrail data events of S3. And there is a finding severity given by default from the Amazon, which is low, high, depending on the severity of the finding. Now that we have touched what the basics of GuardDuty is, let's move to the current challenges or the detection approach being followed widely across the industry. Yeah. So as I said, I worked in 5 companies, and then at least I have 4 connections in each company, and then they worked in multiple companies. When we meet, we discuss what are they doing in the cloud with GuardDuty, and then how is the detection mechanism. This is what we see. Everybody, if not for major 100%, majorly about 75% of them are using just GuardDuty based on severity. If the log says severity is greater than 7, we call it high severity, and then keep it as an alert. And then if the severity falls between 4 and 7, we call it median and then operationalize. So we are narrowing down 180 different finding types or signatures, and then creating just 2 or 3 detections, and then making it into production. But what is the problem with that? Because we are not having any environmental context, or we are not doing any baselining, what happens with that is like it creates a lot of noise. It creates so many alerts that it creates alert fatigue among security analysts. And then in an operational setting, we call it, whenever there is a surge in alerts, they constantly keep asking for allow list or excluding certain signatures. And then it in turn leads to a situation where we kind of start excluding signatures or different finding types. So we create gaps in our own detection pipeline. And then there's a lot of false positives, and because we are excluding all the signatures, there are missed threads. It's like there is an ocean that we are trying to control with a small single gate without any context or without any profiling. And as an outcome of that, because of the increased alert volume, there is alert fatigue within the security analyst. And with the visibility gaps, whenever there is a discussion about efficacy of GuardDuty in general within the executive, because there is no threats identified or because of lower true positive rate, it tends to a situation where we feel that low confidence on GuardDuty that it's not effective. But is that really ineffective? I don't think so. But it just needs the right context to make it more effective, and then how do we use it? Let's take a bare minimum example that let's install a security system within a home, and then the security system says there is a threat with red colored garments in the house, and we can easily identify that yes, there is a threat, and that is true in its sense. But we expand the same system to a street and then call it, because it worked in a single house, it will work. But in a street where there are hundreds of people and there are hundreds of people wearing in red, GuardDuty system still states that there is a threat in red color. But which one? We don't know, because we don't have a profiling. We did not have environmental context. So we'll end up in a situation where we have so many things to narrow down until we find out the actual threat. Let's take an example of one of the IAM signature or the finding type. This particular signature is meant to do a discovery pattern checks, where it looks for get events or describe events, list operations within the cloud account. And then whenever there is event match, that will trigger alerts. And if we take a look at the hits or alerts that it generates in a real setting or real environment, there are so many, like hundreds of alerts in the last 24 hours. And if we narrow down and then see what are those user accounts that are generating so many accounts, mostly we see they are from CSPM user accounts. Usually CSPM are the cloud security posture management ones, right? So they are meant to do discovery scans, and they are meant to profile the environment and have an inventory. So this is subjected to be benign activity in an environment in a large scale. So if we expand the same single account concept to a multi-account, we tend to see there is so much of noise. And because we operationalize this kind of alert within a severity-based concept or approach, we see this alert or this finding type as noisy. And then we get a request, detection teams, to exclude this signature because this is benign, this is not even actually finding any threats. So because there is so much noise, we tend to allow less that as well. And we kind of create our own gaps within the alert pipeline. This is like, they say one home is happy home and then a single security system works better. But if we expand the same thing to multi accounts, we end up in a situation where there is lot of uncertainty and lot of noise. All right, so we discussed very fast that the current approach is being followed majorly across the industry, and there are very less organizations that are very advanced. We think that doing complex things or more advanced things are the ones only to do it, but we miss out on doing things very fundamental, which are basic. Let's move to a new perspective of how it can be done. And then there are multiple ways how you could do it, but we'll just explore the one that worked for me and then one that could work for you as well. We'll go to the first step where we identified there are 180 finding types in the Amazon AWS, and then we map all of those 180 to the resource types. Like out of 180, there could be 20 for IAM, 15 for EC2. We categorize all of them and then map it to resource types. And then the second part, we should be knowing our own infrastructure. We should lay out a learning curve that we understand our own architecture. What are the infrastructure components that are benign? Like we understood that CSPM user accounts are meant to do discovery scans. Those sort of things are something that we need to gather well beforehand before doing anything. And then we need to also baseline what is normal in the environment and what is not. And the third step is that we need to bucket all the signatures or the finding types and associate them to each resource type. For example, there are a number of finding types for EC2, S3, and then IAM. So the second step is bucketing all of these into different categories and then understand each finding type. It's not like, okay, we have hundreds of signatures and then we have a tendency or we have urgency to onboard the GuardDuty. Executives are asking to onboard for the coverage. We do a severity-based detections. We end up in a same situation. So we need to take some time. We need to do assessment of all the signatures, what are relevant, what are not relevant, and what does it say, what does it take. And then the next step is to categorize an alert grouping. So let's take an example of IAM. So let's say there are 20 finding types for IAM, and then we need to group closely related finding types to form one unique detection. For example, on the left side, there are 3 finding types, which is root credential usage, password policy change, console login success. All of these can form one single detection. They are very closely related to policy violation or a compliance thing where users are not supposed to do in the production setting, but they're still doing it. And then on the right side or on the down side, there are all the anomalous signatures are combined to form one unique detection. It becomes easier in a production setting where if there is a noise or if there is a benign activity that we need to consider it as baseline and then allow list, we only do that exclusion to this particular signature and not to the entire alerting system like we do for the severity-based detections. This is one of the Splunk query for the IAM detection that we just spoke. You include all the finding types, and then in this third line we apply this particular detection only to certain accounts, right? We are not doing the same alerting for the entire BUs or all the BUs that you have. You select a certain environments or BUs and then know their environment, their baselining, and then you apply that individually. We are not going to apply the same thing for every BU. So each production environment might have a different compliance or policies, and then the test environment might not have anything at all. So we need to treat everything differently. And then at the end, you can have its own allow list or exclusions where we learn the baseline when we productionize the alert and then have the baselining added to the current existing detections. In a similar way, like how we did for IAM, we could expand that assessment towards all the 180 different signatures and then form multiple variance alerts. So in a current setting, we only have maybe 2 or 3 high critical or high medium low, but we go from that direction to a more granular alerting system where we have plenty of alerts associated with resource types or a combination of patterns that we need to identify and detect. So binding it together, we learned that what is GuardDuty and then how many signatures are there, and then why we need to understand all of those finding types individually, learn what it is, and then learn our own infrastructure, our own architecture, do a baselining of what's normal, what's not normal, and funnel all the signatures or threads that are relevant to your own infrastructure. When you enable GuardDuty, fundamental GuardDuty enables certain signatures by default, but let's say there is EKS or Kubernetes usage heavily in your environment. You need to enable EKS additional advanced protection as well. So that is something that you will need to do it on your own. It's just a direction that this is the way we have to do it. And then you add that to your alert pipeline and then use orchestration to make analysts' lives easier. So as an outcome of this particular new approach, it's not a rocket science, it's very simple thing, it's very fundamental perspective, that doing this drastically reduces the alert volume, but keeping the actual threats intact, where we identify the real threats and then increase true positive, increases the morale of security analysts, and reduce false positives obviously leads to no alert fatigue. And just to recap or do a summary, that we learned that one single security system at home works very well, but we expand that to the entire state without any environmental context or profiling. It fails to do its job. And we also learned that controlling an ocean or a flood with a single gate might not be very bright idea, but understanding to build a dam and then have multiple gates to control the flood and then release water as and when required is something that is needed. And the profiling is something that we need to do for sure. In the same example of that particular street, we profile each individual within the street, that who is a neighborhood, who is a resident, and who is not. And when we do the profiling and then apply the same security to the street, we end up catching the actual threat, no matter how many red colored clothing people are there within the street. And at the end, we tend to catch the threat and then finally reward for our own work. All of these images are AI generated. They are not very complex to design. And let's move to conclusion. So key takeaways is that it's not very complex, that doing the new approach is very tight or tough. It's very simple to understand what are the signatures available within the GuardDuty, what is relevant to our own infrastructure, what are the accounts that are production, that are dev, and then what is the baseline for the environment, and apply this particular perspective to the alerting. Thank you. I remember, so I think this holds good. The first challenge, it's very simple. Open up your LinkedIn apps and then search my profile. The moment you see the next slide, there is a challenge. We have 1 minute, and then it goes like this. You see a challenge, and then you find out what's the answer, and then DM me the answer, whatever it is. Whoever gives the correct answer first, I think that will be the winner of the first one. It's the same thing for the second one as well. So when you're ready, just give me a wave so that I'll move to the next slide. I mean, this is self-promoting, but it's okay.
It requires premium to DM you right now.
What's that? I can't hear.
It requires premium to DM you on LinkedIn.
Oh, is it? Oh, no.
आपके लिंक्डइन में ये मैसेज करना चाहते हैं प्योर हिंदी में, ये मैसेज करना चाहते हैं तो प्रीमियम आ रहा है.
Is it for everyone? अच्छा ठीक है, मेरा मोबाइल नंबर ही देता हूँ. ठीक है? Who wants to go first? ठीक है, write down my mobile number. 99-622-143-20. All good? ठीक है. Identify one GuardDuty finding type that is specifically related to Bitcoin and DMU or LinkedIn. LinkedIn is not relevant anymore. Yes, Bitcoin related finding type. All right. Vaibhav Lakani. Who's that? Perfect. Okay. Okay, don't say any more answers. Let's have second one. Ready? Identify one GuardDuty finding type that is specifically related to pen test. Who is N Gupta? Okay, got it. I think both of you can come down to the stage. Can we have some claps for those? I don't want to be biased, so come down here and then close your eyes, pick anyone. Thank you. Thank you, folks. Nice turn. I think we can have a Q&A if anyone has.
Hello.
Hello.
Hi, my name is Prathamesh. So my question is, so where are you collecting this finding types? And if it is publicly, is it publicly available, or is there, or is it a closed source completely?
It is publicly available. Once you go to Amazon GuardDuty doc site, all the finding types are publicly available.
Okay, so all are open source.
All of those, yes.
Perfect. Thank you.
Hello. So, how does GuardDuty handle false positive in its threat detection process?
What's that?
How does GuardDuty handle false positives in its threat detection process?
False positives.
Yeah.
Okay. So when we ask false positive, is it the finding type itself is not actually detecting right, or it's not relevant as a threat in your environment?
Not relevant.
Not relevant.
Yeah.
So if it's not relevant, that's something that we need to feedback or give feedback to the GuardDuty, where they'll fine tune the signature. If it's something that is false positive due to the nature of benignness within your environment, that is something we need to work within an environment.